Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello and welcome to podcast number 104 for the month of July 2023. I hope it finds you well. But without further ado, here we go, the puzzle of the month. X plus xy plus y equals 90. Now, if x and y are positive integers, can you find the sum of x and y? Okay, that's interesting. Rewind this podcast if you want to hear that again. Have a think about that, and I'll be ready with the answer this time next month if you haven't figured it out for yourself before then. So, while you're pondering, I'll ramble on a little bit about some of the new resources added to the Transum website during this last month. First of all, the integration exercise now has new levels, worked solutions, and a help video. Can you ask for anything more? The new levels cover integration by substitution and integration by parts. The common trig ratios exercise was originally only available in degrees, but it now has a companion set of exercises in radians. So thanks Angus for the suggestion to do that, and it's now ready for your senior students. It's my birthday in July. I'll no longer be both a square and a cube, but I will be the product of two prime numbers. Now, if you would like to know the date of my birthday, so that your cards and presents can arrive at the right time, you can find clues on the newly created Happy Birthday page. And while putting together some activities for birthdays, I finally learnt the method for calculating the name of any date this century, the day name, the weekday name. It's a version of the Doomsday algorithm written by John Conway. I've simplified it a bit, so my simplified version only works for dates this century, but I think it's actually quite a useful skill. The number of times I'm trying to work out the day of the week for a certain date, well, now I can do it. Any year from 2000 to 2099. It's a skill I've long admired in others, and I always thought it was just far too complicated to commit to memory. But I've now come up with this step-by-step set of instructions, and you could be a date genius too. So have a look at that on the birthday page. By the way, all the things I'm talking about here in the podcast, the links to the pages can be found at transum.org/newsletter. For many of you, the school year concludes in July. As always, I hope these last few lessons and the holidays are used to expose your students to some exciting, interesting, and extraordinary mathematical activities, such as the ones I've put together in the end-of-term maths collection. It would be really sad if those last maths lessons of term were wasted. Quite often, from my experience, special school activities take place during that last week of term, and as a result, pupils are taken out of normal lessons, leaving you, the maths teacher, with only 2/3 of your normal class and an expectation to do something different. So it would be a crime if you just put on a video, unless it was a maths video, or simply told the pupils to get on with their own pastimes, when there are so many out-of-the-ordinary mathematical activities you could be doing. So have a look at the link in the newsletter to the end-of-term activities, hand-picked and, collected by me for many, many years. I've built up my collection of activities you can do at the end of term, and I'm sharing them with you now, so enjoy. Students are encouraged to continue their learning during the holidays because research indicates that by the end of the long summer holiday, pupils perform on average 1 month behind where they left off in the spring. So, this school holiday activities collection, again the link is in the newsletter, has suggestions for activities that will keep children thinking mathematically while having fun and learning new skills. You could give the link to the page to all of your pupils. It's not too late. Even if you've broken up already, you could still send it to them by email. And even if only half a dozen of your students take the time to do one of the activities, that's better than nothing. So, by the way, let me know if you have any other ideas I could add to this collection. Thanks. The starter of the day for the 4th of July is themed on American Independence Day. And I always think it's ironic that most of the American students who might appreciate the reference won't be in school that day because it's part of their long summer break, so won't see it. But it's there because many UK schools are still in session, and Australian schools and New Zealand schools and all the other places in the world that access Transom. Continuing the trend of the last few newsletters of letting you know of my experience using artificial intelligence, this month I asked ChatGPT, with the help of 2 plugins, one from Wolfram and the other called Show My Diagrams, and I asked it to gather data and then produce a bar chart showing the frequencies of the first digit of country populations. So if you can imagine it, well, if you go to the newsletter, you don't have to imagine it because I've pasted this bar chart into the newsletter. But basically, the bar chart is an example of Benford's law. Because if you can imagine on the horizontal axis, we've got the first digit of the country's populations. And on the vertical axis, we've got the frequency, the number of times that those first digits occur. And surprisingly, rather than being a roughly equally spread out distribution, 1 to 9, there are far more countries whose population begins with a 1 than begins with a 9. And the graph sort of, the bar charts get smaller and smaller and smaller as you go from left to right. So this is an example of Benford's law. If you haven't come across it before, look it up. But then I decided to go a little bit further, and I decided to ask ChatGPT if it could come up with any interesting facts about this phenomenon.
Absolutely. Here are 3 interesting facts about Benford's law. Firstly, it's an unexpected distribution. Benford's law is counterintuitive because it predicts that 1 will be the leading digit about 30% of the time, while 9 will be the leading digit only about 5% of the time. This is contrary to the uniform distribution that many people might expect, where each digit from 1 to 9 would have an equal chance of being the leading digit. Next is the notion of scalability. Benford's law is scale invariant, meaning it applies regardless of the unit of measurement. So whether a country's population is measured in thousands, millions, or billions, the distribution of leading digits should still follow Benford's law. Finally, here's a real-life application. Benford's law is used in forensic accounting and fraud detection, because when people make up numbers, they often fail to follow the distribution predicted by Benford's law. This can be a red flag for investigators.
So then I wondered whether Benford's law would be suitable as a topic for coursework. I asked ChatGPT for 3 probing questions for further investigation.
Number 1. Does Benford's law apply to all countries? While Benford's law is often seen in many sets of naturally occurring numbers, it would be interesting to investigate if there are any specific countries whose population numbers do not follow Benford's law. Number 2. How does population growth affect Benford's law? As countries' populations grow, the leading digit of the population number can change. It would be interesting to investigate how population growth trends might affect the distribution of leading digits over time. Number 3. What other demographic data follows Benford's law? beyond just population numbers. It would be interesting to investigate what other types of demographic data, for example, age distributions, income levels, etc., follow Benford's law.
Talking of populations, the 11th of July is World Population Day and is highlighted with the starter called Absolutely Everyone. That counter that ticks away at the top of the page has long passed the 8 billion mark and continues to increase. This starter allows you to choose your own questions from the selection that's provided. You just drag the questions up that you want to use or click on them. And it's fascinating that if you think of the population figure in other terms, you can see just how big that number, 8 billion, is. Okay, now asking for a friend. Weight is continuous data. But if weights are collected to the nearest integer, is the collected data now discrete? And the reason I'm asking was a little question on one of the exercises where you had to work out the range of the data. And I wondered that because it had been collected as discrete data, because it had been rounded, whether you should take the error intervals into account when you look at the range. Anyway, asking for a friend, of course.
You can find Transum Mathematics at www.transum.org.
Now, in the newsletter, there is a photograph that I took when I visited my mum, who's 91, and it shows a little paper construction she'd made at her fortnightly ladies class. And I thought it was fascinating, actually. It was lots of hexagons made from paper, stuck together to make a beehive type construction. And just to give you that idea, there was a paper bee pasted on the outside of it. And I thought, wow, lovely construction. Maybe that would be of use in school. And Transum has got a, what's it called? A paper constructions, that's what it's called. A paper constructions page. So I've added that as an extra idea to the ones that are already there. Yeah, you can get quite a lot by folding paper. Obviously, recycled paper is the way to go with that. But yeah, looks really good. Okay, we are now finally at the point in the podcast where I give the answer to last month's puzzle. The answer is -1/2. Okay, let's just remind you what the puzzle was. X squared equals 16 to the power of x. Find the value of x. And I posed this puzzle knowing that I'd found out the answer by drawing a couple of graphs, finding where they intersect. But I wondered if there was a more elegant way of solving this problem. Well, a number of people wrote in with the correct answer, and the top 5 were Pauline Johnson, Chris Smith, Rick Blair, Kate Cooper, and Nigel Fern. So, I initially simplified the equation by finding the square root of both sides, but then came to a dead end and didn't quite know what to do next. So, after having used the graph plotter to find the answer, so Rick wrote in to say, I used logic to eliminate positive and negative numbers greater than 1 and positive fractions, leaving just negative fractions, and using the first negative fraction of 1/2 solved the problem. So I stopped. Okay, that was Nick's method. Very good, very logical. So, if you have any clever ways of solving today's puzzle, which was right at the beginning of the podcast, please let me know. But otherwise, that's all for now, apart from saying that calendars, their days are numbered.
Thank you for downloading and listening to the Transum podcast. You can find the website at www.transum.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transum subscriber.